Bismillah ar-Rahman ar-Rahim, wa salatu wa salamu ala nabiyina Muhammad wa ala alihi wa sahbihi ajma'in. Okay, so we are still in chapter 2, Python for data science, in the course Introduction to AI in Data Science. And today I'm going to continue talking about Python programming language and from package setup perspective. So I'm going to introduce the concept of virtual environment, how to set up a Python package and also create virtual environments. So let's review the Python package structure as already introduced yesterday. So you can create a Python package as a folder, and inside this folder you will create Python scripts, which we call them modules, and the init.py, it's a special file, and one of the purposes of this file is to initialize a package, okay, and also helps in the management of sub packages. You can also put some code here, but by default, it's an empty file unless we need to put code inside. And this is an example of a Python script of a Python module that contains a method and an import function and also calling that function. So there are different libraries. This is just a reminder of yesterday's lecture. There are standard libraries that are already come pre-installed when you install Python by default, like for example JSON, datetime, sys, and OS, and several others. And there are other libraries that you need to install yourself. These are third-party packages. It means that they are developed by the community or other developers or even by yourself, as you are going to learn today on how to create a Python package. And you can distribute it so others can use it as a third-party package. And usually we use pip, which is the command line for package management in Python. And it extends the functionality of Python for specific use cases like data science, data analytics, web development, and other. Okay, so the first thing is the need to create a virtual environment. Usually when you install Python, you can install any library into the main environment of Python, but this is highly disrecommended, not recommended. Why? Because usually when you work on a computer machine, you might have different projects, and this project can have different type of dependencies. It means packages that you need to install, and in many cases this dependency may not be compatible. I personally faced this issue several times. For example, if you use a particular old library, it may require some dependencies that are old. Sometimes when a package is updated, it will compromise other packages. So there could be a conflict between the packages. So this is why when you have a project, this project must be isolated into what we call a virtual environment. A virtual environment is just a container where you can put all the libraries and code related to one particular project or multiple projects that do not have any conflicts. So there are two different ways, and this is pretty much explained with demonstration in the video that I have shared with you today. So today you need to go through these videos and try also to apply it, but these are the commands that you need to execute. So first of all, you need to install venv if it is not installed using Python command. And now here there is a trick. So Python, usually it refers to Python 2. In some other computer machines, it refers to Python 3. So if you write Python and you know that Python 3 is installed and Python command doesn't work, it means that you need to write it as Python 3 command. There is some packages that you can install that will map Python 3 keyword to the Python keyword. This is if you don't have Python 2 installed and you want to use just the Python keyword for running Python 3. You can make an alias from Python to Python 3. Okay, this is just depending on your system how Python was installed. It might happen that the Python command doesn't work and you need to run Python 3. You will observe this on my machine, especially when I worked with the pip install in the beginning. Okay, and then to create a virtual environment, you will use the syntax python-m venv, and then you give the name of your environment. Okay, so this is going to create a virtual environment, and you need to activate this virtual environment by sourcing it. So this is how to do it on Windows, and this is how we do it on Linux or Mac operating system. And you can also deactivate this one. So let me show you the example. So this is the 316 workspace that we have created, and inside the workspace, and you can create your virtual environment. It's not recommended to create the virtual environment. It will be created as a folder, but it's not recommended to create it into the package, because later on the package you may upload it to GitHub or to other repositories, so you don't want to port this virtual environment. This virtual environment, you can reproduce it on any machine using different ways. One of the ways is setup.py that I'm going to introduce, and another way is requirement.txt file that will list all the libraries and that you can install it into your virtual environment. But for now, this is a virtual environment. It has a binary. It has an activate.css file that you need to execute in order to run. And this is why here we need to run /activate. So it's going to source these script files in order to activate the virtual environment. Okay, so just let me go from this one. Deactivate. This is for conda. Okay. Now, if I want to, so this is now on the physical machine. I don't have any virtual environment, and my virtual environment was created in the workspace. It's called CS316 virtual environment. I created using the same series of instruction. And now, if I want to activate it, I will do source / CSV.env, and then bin, and then activate. And look now, it has changed the virtual environment to the selected one, to the activated one. And then with pip, you can just do deactivate, and you will move outside from the virtual environment. So inside this virtual environment, you can do pip install any library of your choice, okay, and it's going to install it without compromising other virtual environments that you can create. Okay, for example, I can install cball library. I think it's already installed. I already installed in setup.py. Okay. So this is the way on how to create a virtual environment with the pip package manager. Now, if you prefer to work with Anaconda, which I introduced yesterday as another Python package management tool or framework, the syntax is similar, but it's a little bit different. So instead of using the pip, we use the conda command. Okay, conda create -- name my am. It's going to create a virtual environment with, of course, this assumes that Anaconda is already installed on your system. And then same thing, you will do conda activate. So we're not going to use source here, it use conda activate and the name of the virtual environment. And this is more flexible because when you source the pip environment, you must be into the same directory. But with conda, you can call it from any other directory. You don't need to be into the same directory of the virtual environment as in the case with pip, because with pip you need to source it. Yes?
Doctor, I didn't understand why do you need to create a virtual environment?
Yeah, this is what I explained in the beginning. I said when you have multiple projects, the libraries can be conflicting. Okay, not compatible. Okay, and this non-compatibility, it may have an issue because the code requires a particular version of a particular library. If you change the version, the code will be compromised. Sometimes the developers, when they upgrade from one version to another, especially if the upgrade is major, it can be non-backward compatible. Okay, so the virtual environment is like an isolated container for the code. Is it clear for everyone?
Yes.
Okay, it's an isolated container for the code, so it doesn't conflict with other projects. And this is for complex projects, yes.
So you mean the virtual environment is like makes the code independent from library?
Isolated. Okay, so you have 10 projects. You can create all of them into the same environment. If you are lucky, there will not be a conflict. Like in this project requires 3 libraries. The other project will require 10 other libraries. So you will install all these libraries into the same environment. There is a chance they will be conflicting. And the environment will be very large. So even later on, imagine that you want to take one project to another machine. You are going to take all the libraries, whatever those that you use in this project or that you don't use in this project. So it's going to be very large and heavy. So when we isolate the environment, we can actually know and specify what are the libraries only needed for that project, and we can replicate the same environment into another machine. So if you want to send your code to your colleague, you will send him, for example, setup.py, which contains the list of library. You just need to install this into his virtual environment, and the code works immediately. Okay? So this is very, very useful in large projects. But in small projects, of course, you can do it at smaller scale. Okay, this is how to deactivate, conda deactivate, and you can also remove the virtual environment using conda remove, and then the name of the environment -all, it will remove everything. So this is what we do. So already now, let me go outside of this virtual environment, and now if I want to activate the virtual environment that I have created, it's CS316. I think it's Env and then conda. Yeah, look. This is the virtual environment that I've created using conda. And now this is our, if I want to deactivate, I will use conda deactivate, and now I'm in the main space. Okay. So this is Anaconda Navigator. You can also create an environment from the Anaconda Navigator. You have here environments, and look, you can press the plus sign if you want to create another one. Yeah, create. Look here. You have here a button, create. You can create the environment. You can select what is that Python version that you want to create. Okay, and then it will be created. So this is a graphical interface that replaces the command line. And after that, you have a repository where you can search for other libraries. For example, if NumPy is not installed or pandas is not installed, you can search here and add it to the virtual environment that you have selected among all of this. Yes?
Doctor, if it's downloaded in the base, you don't have to download it in the environment, right?
No, the environment will be completely isolated. If you work in the environment, it will not see the base. It will not see other environments. It's a standalone framework, okay? It's a standalone environment that doesn't see any other thing. This is the objective of isolation, is not to have a conflict with other type of environments. Yes?
Do you have to download the libraries with every environment?
Sorry?
Do you have to download all the libraries again with every environment?
It depends. An environment is created for a project, and the project will have a requirement for particular libraries, so you download the libraries that you need for that project. The environment doesn't need anything. It's your Python package that will require some libraries. Okay? And you know, this is very well explained in the video with the illustration. Okay? So you can get more details, practical details about what I'm saying. Yeah. Any question? Okay. And then when you are inside a particular virtual environment, so you can use pip install and the name of the package. Now, as already mentioned, I can use, now, look, I am in the main workspace. I can do pandas. So pip is not installed over here. So let me just go to the conda activate. Okay. So now if I want to install any package with conda, I can use conda install and the name of the package. So most of the packages are available under the conda distribution. But if they are not available under conda distribution, you can still make pip, conda install pip. So this will install the pip package, okay? And you can use pip to install packages inside conda. I explained this in the video, by the way. And this is very useful because some of the packages, they are not available under conda directly, although the majority of the packages are available in conda there. Okay, so it's already installed. Now I can do conda install pandas. It's already installed, by the way. I installed it with pip, and now it's going to run the installation. Okay, and it will install all the dependencies. Look, I installed pandas with pip, and now with conda it actually installed a second distribution. It will override the previous one. And you can observe so many other libraries will come as a dependency. Look, all these libraries are dependencies of the pandas. Now imagine that some of these dependencies, they are not compatible with the dependencies of another library, so they will be conflicting, especially the dependencies that are related to the system level, hardware, or low level of the system. Usually they have conflicts, and you need to isolate the project. Okay, so this is done. I can do also pip install pandas. Okay, it's already, and if I do conda install pandas again, it will say that it's already installed. Okay, so this is the virtual environment on how we can manage them. You can make conda list or pip list. Okay, pip list will show you all your all the libraries available. We can do conda list also, show you all the libraries available. Look. Okay, so we have already installed Seaborn, we have installed Panda, Pillows, and some other libraries. Okay, so now let's set up the Python package. So usually a Python package will look like this. Okay, so we have the package name, and inside the package name we're going to create also another folder that we call package name. Usually we're going to put all our modules inside. So later on, when we want to import them, they will be important as package name dot the module name dot one of the methods that exist into the module. This is the how we structure. So we can have also a test folder. These are conventions, by the way. You can have also other folders inside the same folder, and you will have setup.py, and this folder is a script for packaging and distribution. So we will put it as a package, could be executed or uploaded to PyPI repository or installed in any machine. And the README file, this is for documentation and providing a tutorial about your package and how it can be used. And you can put a license, whether you want to allow commercial usages or only education. If it is open source, there are different types of licenses. You can read about them and put whatever is appropriate for your distribution. So the first thing that you need to do to set up the Python package is to create a setup.py. And this is a configuration file that provides meta information and metadata to describe your package. So usually you can find things related to the name, like for example the name of the package, the version, okay, and the version should be incremental. When you submit one version to another, it must be incremental. So usually here you have, if you have a major revision, you can change the leftmost number. If it is minor revision, okay, if it is just bugs, so we change this number. Okay, so these are meaningful, these three numbers. They are not random. I don't know whether you have done already this in software engineering or in computer science, but usually in software management, this is what we call version tracking. Okay, and it's very important. We have three numbers. Put your name as an author if you are the author, your email so other people can contact you whenever they find any bug, so they can communicate with you. You can put a description of the package. There is a short description and the long description. The long description can be taken from the README.md, so you don't need to rewrite it again. That is a way on how to do it. But of course, your README.md file must be defined. If it is not defined, when you run or execute setup.py, is going to return an error because the file doesn't exist. If your package is located into a GitHub repository, you can put also information about the GitHub. And this is a classifier providing more information about the package. It uses Python 3, it has an MIT license, and it's independent from the operating system. And this is the important part, is putting the dependencies. Okay, so here I have four dependencies: NumPy, pandas, requests, and matplotlib. You can put, look here, I specified that the version should be greater than a particular one. This you can impose a constraint if you don't want to work with previous versions. But by default, if you don't put any version specification or constraint is going to install the latest stable version available. Sometimes it may make a conflict, so doing constraints into big and complex project can help, because so to prevent any issues when the versions were upgraded. Okay. Okay, and the entry point defines the entry point for creating command line scripts. And after creating your setup.py, okay, and this is an example here of setup.py in the package. Yes, you can take any setup.py and just change the information. So the keys are there. There are possible other keys as well, but the most important thing is the values that you will put for your package. So it has this structure. Okay, it may have additional information depending on what you want to add. Okay, here now this is the setup.py in this example. Okay, I specified the libraries without putting any constraints, so it will install the latest ones. Okay, here there is Python require, so I will impose that the Python version is greater than 3.9. And yeah. And this is the entry point over here. So another important thing, if you want to have a professional design of your Python package, is to add a README file which provides a documentation for other users. Okay, especially if you want to develop a library that will be used by others. If you don't provide how to use it, what are the different features, so nobody is going to be able to use your code. Okay, so usually you start by an overview presenting the description about the package, its purpose, what kind of solution it provides, its main features, and also how to install it. Okay, and this is possible only if you upload your repository into the py.py repository. I'm going to introduce this into a video lecture. And also you can upload it to GitHub, so it can be available either as a source code if it is open source, or it can be also provided as a pip install package. And of course, in any case, when you do pip install, is going to import the source code and put it into a special repository for later on to be executed, interpreted and executed. Yes?
Doctor, you're using the workspace here, right? Not
Yeah, I created the workspace, then the package, and then the Python module. Okay. So that's an example about also you need to put the usage, how to use the package, sample of examples. Okay, if you define string utilities, method, this is just an educational illustration. Depending on what kind of method, usually you need to provide a tutorial on how to use this method, what are the modules, what are the functions, the input, the output, and so on. And now, this type of task people don't want to do. It takes time. With ChatGPT now you can just do it professionally and in a few seconds. Okay, so I do recommend. Large language model like ChatGPT are pretty much useful in this kind of clerical work. But for programming, you need to do it yourself, okay, especially for this course. But for writing professional documentation, if you don't want to spend time, usually just give it the code. It's going to generate you documentation pretty much simple and easy. Okay, you need to put also the license, the contact information. There is no consensus, but this is like a general template. If you want other people to contribute to your package, you can also put some additional information. So what is py.py repository? It's like GitHub, but for distributing Python packages. So you can go to py.py through this link, py.py.org, and basically you can search any available package. Okay, so the Python package index, Python index, is the official third-party software repository for Python. And it allows developer to distribute their Python software and libraries to other users. And the key feature, okay, it offers package management because it's easy to install from py.py using the pip command. Okay, so conda, it has also its own repository for deploying this, for also installing Python packages. It's searchable, so you can search any package, and it's community driven. Anyone can contribute. You can create your package and upload it just by applying the same instruction I'm going to mention here. And this is, for example, I would like to look for NumPy. You will find a lot of possible libraries, and of course you need to see what is official library, because I can create a library that I can call NumPy with some modifications. Also, it maintains the versions, so if you submit several versions, it can track these versions, and you can revert to any version that you want.
Doctor, I assume there's naming restriction?
Yeah, there should be a naming restriction. I'm not aware about the exact details.
Like, for example, can I create a package that's named exactly scale xi?
I don't think so, no. There will be a conflict.
Yeah.
Yeah. So this is one of the packages that I've created, and I posted here. So usually it must have a documentation. This is the short description. So everything comes from setup.py. This is why it's important. If you want to make something professional, if you work on a company, it's important to do everything properly. So later on when you deploy it, you don't have blanks everywhere. You have full documentation. So it's professionally designed. And now when you deploy, it's going to show you the latest version and the way how to install. If you do pip install scale xi, for example, it's going to download the latest package. And also you can go to the release history. Sometimes, for example, if there is non-compatibility and you have a code that is with the previous version, because now the versions are not compatible with each other. From one version to another, I can make substantial changes. And it's still under development. And this is where the long description is going to be displayed. Like in GitHub also, in the README file, you can reuse it in the same way. Yes?
Doctor, if you want to maybe update a package you already have,
Yeah.
how would you do that? Do you just install it again? For example, you want to update your NumPy package.
Yeah, you want to, no, you cannot, NumPy is not my package.
Yeah.
If I want to apply my own package, you do your modification, you change the version in setup.py, and there is a way that I'm going to show on how to upload it again. It's like GitHub. GitHub, it has instructions to upload, and PyPI, it has its own instruction. I'm going to show you just in a while. Okay, so as I already mentioned to you, versioning is very important. We must use semantic versioning, and we follow this standard. The first number is a major revision. Usually, major revisions are not compatible with each other. So, مثلا, Python 2 and Python 3. From the way Python 3 was released, it was non-compatible with Python 2. Okay? But for example, Python 3.9, it makes changes with respect to Python 3.8. There could be some incompatibility, but much less between major versions. Okay? And 3.9.1, maybe it fixed some bugs. It has improved. So 3.9 should be all compatible with each other. Okay? 3.10 should be all compatible with each other. But if the major or the minor changed, there is some risk that there is incompatibility. And we have a patch. Patch, it means I discovered the bug, so I fixed it, patched it, and uploaded the patched version. This is how we understand it. Okay? And usually you start your 1.00 version when you reach something that you consider stable. You know, now in my case, I'm still in 0.4 because still under development, still not stabilized. Okay? And you need to do the documentation, okay? And you need to test it before uploading to the PyPI. And the way, you know, you can try it. I'm going to release a video. You create an account here. There are some kind of authentication instructions that you need to follow. And then to install, you need to go to your repository and use pip install twine. It's going to ask you about your credentials for the PyPI. You provide the credentials and it will be uploaded as what we call a wheel. This is the terminology that we use. A wheel is a distribution, is a Python distribution. Okay, so the way how to provide your credentials can be two different ways. You can use a hidden file that is called .py.pirc, and here you can specify you want to use index server PyPI, and you provide your username and password, those that you have used to create your account in PyPI website. So in this case, you don't need to provide the same credential information each time you want to upload to the PyPI servers. Okay, so you put it into the same repository, to the home directory of the package, you make the configuration, and then it's going to work. When you press this one, it will just upload if there are no errors. The other way, it's just to call twine upload dist slash dash star, and it's going to request you to provide the credential every time that you call this function. Okay. So how to create a wheel? And a wheel is basically a Python distribution of a Python package. It is the standard format for distributing Python libraries and application, and is designed to be faster and simpler to install compared to the source distribution. So usually when you make pip install dot into your directory, is going to create .tar.gz. This is like a compressed distribution that you can also share with others. But it has some limitations in terms of speed, in terms of easiness. So there is another extension for the wheel that is called .whl. It refers to the wheel distribution, and this is what is going to be uploaded to the PyPI repository, and then you can recover it using pip install. So if you don't have a wheel distribution, pip install is not going to find that distribution to install it into your system. Okay, so the advantage of using the wheel is the faster installation, easier compatibility, and the ease of use. You can just do pip install. If you have a wheel distribution into your local machine, you just call it. If you don't put .wheel, it's going to search it from the PyPI repository. So usually pip install is going to search locally. If it finds the distribution, it's going to use it. Otherwise, it will bring it from the remote repository. And this is how your package will look like. So these are the packages. You will have a dist folder that will contain the wheel file. Okay, so the dist will contain the wheel file. You have the build folder. It contains temporary build artifacts created during the package build process. And mypackage.egg/info, it's a directory that contains metadata about the package. Okay, so these are the three main new added fields after you do pip install and creating the wheel. This is just a summary of building the package using Python setup.py. sdist and bdist wheel is going to create these two files locally. And then after creating these two files locally, we will upload them. So this is just a description of these two files and how they are used. And then we can upload them. So before uploading them, you can use them to install them into your system onto another system. If you move the .tar.gz or the .wheel into another machine, you just need to make pip install and call them. If you upload them, you can also do pip install. Look, like I'm here. I'm inside the package, cd CS316 package. Okay, I'm inside the package. I can do pip install dot. So this is going to install all the dependencies and install the whole package locally. Okay, so you can download the package from GitHub and do pip install dot. It will do the same thing. If the package is available on PyPI, you can also do pip install and the name of the package that you have uploaded. Okay, this is how to upload. Is twine upload dist/star.wheel. It will upload all the wheel distributions available locally, and later on you will be able to find it onto the website, and you can use pip install the name of the package as here in order to download it. Now imagine every time that you want to upload, you need to memorize all this syntax. It's difficult to write them. It takes time. The good thing is that you put this into a bash file. Like in my case, I created a function into the .bashrc file, or in the Mac, it's the bash profile file. It's called upload package, and here I'm going to remove all the old distributions, build the distribution, create the new package, building the package, and uploading the package. Okay? And just calling this method, it will do all the dirty work. That's one of the things, from practical perspective, as a best practice, create shortcuts. Like calling the name of the method inside your package, it will do all the work instead of just memorizing. And at least it's going to take 1 minute writing all of these, or just making it in a few seconds by calling the name of the method that you can memorize and write quickly. This is to optimize your time for development, for the update, and so on. It's always good to have these good practices. That makes the difference in terms of productivity, professionalism in writing the code. Okay, save time. Saving time is the most important thing. And that's it for today. Okay, this is an overview. Please do watch. I made a lot of effort to make the video that illustrate all of this. Watch the video. It's only 20 minutes, and try to do the same thing. Okay, you don't upload the video. Doesn't show how to upload to PY. Wait for me for tomorrow. I'm gonna make that video. But at least create your package with setup.py, with README file. Take my code. I can send you my code and get inspired. Change it. Edit it. At least create your package for the first time.